Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 3014. Minimum number of pushes to type word 1. You are given a string word containing distinct lowercase English letter. Telephone keyboards have keys mapped with distinct collection of lowercase English letters which can be used to form words by pushing them. For example, the key 2 is mapped with A, B, C. We need to push the key one time for A and two times for B and three times for C. It is allowed to remap the keys numbered 2 to 9 to distinct collection of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the key will be pressed to type the string word. Return the minimum number of pushes needed to type words after remapping the keys. Okay, there are no remaps. Sorry, there are no maps for 1 star hash and 0. So this is what the question said. Let me take this example. See here, this is the button phone, right? We have used this to type A. I have to press this 2 one time. To print or to type N, we want to press this 6 two times. For print A, we want to press this 2 one time. But for printing N, we want to press 6 for 2 times. To print Z, we want to press this 9 for 4 times. So this is what the question says. But they have given a condition like you want to print the minimum pushes we need, and we can remap them. We can remap every characters. Okay, let's all analyze this examples. See here. First of all, the word is A, B, C, D, E. So this is the input. I can remap as like this: A here, B here, C here, D here, and E here. See here, A is at the first, B is at the first, C is at the first, and D is at the first, and E is at the first. So we can say I will press one time, here one time, here one time, here one time, and here one time, so that my output will be what, 5, right? So my output is 5. Again, come to the second example. See here, this is my input x, y, c. So x and y are mapped to 2, and c and d are mapped to 3, and then e and f. So e is mapped to 4, and f is mapped to 5. Then g is mapped to 6. Now h is mapped to 7, and I is mapped to 8, and then j is mapped to 9. So we can remap like this, and my answer will be 12. How comes 12? To print x, I want 1, and print y, I want to press 2 times. To print c, I want to press 1 time. To print d, I want to press 2 times. To print e 1 time, and then f 1 time, g 1 time, h 1 time, and I 1 time, and j 1 time. While adding this, we will get the output as 12. So this is what the question states. Now, how to approach this problem? First thing come to my mind is whether we want to remap. Whether we want to remap. No, right? No. Why? Because just see here, they haven't asked us to remap. They're asking us to find how many times we push the button. Okay, how many times we want to push the button. So by observing this carefully, see here, how many numbers are there with the alphabets? I can say 2, 3, 4, 5, 6, 7, 8, and 9. So there are totally 8 buttons. There are totally 8 buttons which are used to what? Print or to type the alphabets. To type the alphabets, we have totally 8 buttons. From this, I can conclude that if my characters in the input are 8 or less than 8, is less than or equal to 8. If my characters if the distinct characters is less than or equal to 8, I can say I'll get the answer as 8. Why? Because if take for example A, B, C, D, E, F, G, H, totally there are 8 characters. No, now 8 characters. Yes, 8, 1, 2, 3, 4, 5, 6, 7, 8. If this is the string, I can map this A to 1, B to 2, sorry, this A to 2 and 3, 2, 3, 4, 5, 6, 7, 8, 9. You can map them to the first character in each and every buttons. Right, right. So this is our first observation. What is our first observation? Our first observation is if the characters, unique characters, is less than or equal to 8, then my value will be the unique characters. Unique characters. Just take for example A, B, C, D. I can take this to 2, 3, 4, 5. So we totally need how many buttons? Just 4 presses. We need only 4 presses. So I will just return the unique characters. So this is my first observation. Okay, what is my second observation? If it is less than or equal to 16. If it is less than or equal to 16, I can map another 8 characters. If take for example, there are totally 16 characters. Initially, I will map 8 characters to the first element in first element in 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 9 buttons, right? But still, there are 8 more characters. Again, I will map them, right? Let's see here. Let me write here 2, 3, 4, 5, 6, 7, 8, 9. Now, observe carefully. If there are total number of elements as 16, here I can put one element, 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 one element. Again, if now I completed 8 elements. Again, I want to fill 8 elements. So put again 1, 1, 1, 1, 1, 1, 1, 1. Yes, yes. So that I can press to print this values. The first values I want totally 8 times. 8 times. To print the second value, I want to press 2 times for each buttons. So totally there are 8 buttons. So 8 into 2, which is equal to 8 plus 16, which is equal to 24. This is what my answer. If take for example 2, 3, 4, 5, 6, 7, 8, 9. If take for example there are only 12. There are only 12 unique characters. I can fill each with 1, 1, 1, 1. Right now I can remap. Now 8 are completed. Now only 4. I can remap this 4 to 1, 1, 1, 1. Now how many presses I need? I need 8 pushes initially for pushing this all 8 elements, plus to push this and this I need 2 times. So 2 into 4, which is equal to 8 plus 8, which is equal to 16. So 16 pushes I require. Fine. So this is my observation number 2. If it is less than or equal to 16, I need to do what? Unique characters plus 2 into unique characters minus 8. Fine. So this should be my second observation. Now, what is the third observation? If it is less than or equal to 24. If it is less than or equal to 24, same applied, but still, first we want to do 8 characters. Then we want to do 2 presses for each and every 8 characters. Then we want to do 3 presses for again the remaining unique characters. So unique minus 16. So this is my formula. This is my observation. Just pause the video and just realize, just solve some example problems so that you can understand why I am using this. Okay. So here it will be what? 8 plus 2 into 8. Here also 8 plus what? 3 into unique minus 8. Unique minus 8. 8 minus unique. Here also 8 minus unique. Right, right. Now, what is the fourth observation? If it is greater than 24, right? Or it can be what? 25 or 26. There are total 26 letters, right? It can be 25 or 26. If it is so, I can say initially 8 for mapping the mapping at the first position, then another 8. So we push for 2 times and another 8 we push for 3 times, and remaining will be either 1 or 0. If it is 25, it is 1. If it is 26, it will be 2 into how many times? How many times? 4 times. I want to press for 4 times. So this can be my last answer. So this is my last case. Okay, here the case will be applied. Right. So these are the 4 cases. Now how to make these 4 observations into the code. Just observe carefully. I will pass this. Just I assume the number of unique characters is, let me take 22. So the number of unique characters is 22. If I can take the 8 characters from this 22, 8 characters from this 22, and map to first values in each letters. In 2, I will map at the first place. In 3, I will map at the first place. In 4, and in everything, I will map at the first place. Okay. So for 8 characters, I have mapped. Now remaining, how many characters there are 14 characters. I will again take 8 characters and map it at what? At second place. At second place. No. There are remaining what? There are remaining 6 characters. Again, I will take the 6 characters and map it at third place. No. Calculate. I have mapped 8 characters as first position. So 8 into 1. Okay. Then 8 plus I have mapped 8 characters at second position. So 2 into 8 plus I have mapped 6 characters at third position. So 6 into 3. By solving this, I will get 8 plus 16 plus 18, which is equal to how many times? 8 plus 24. 24 plus 18, which is equal to how many times? 2 and then 1, 42. So 42 pushes. Right? So this is my result. So let me code it up. Just see here. S is equal to len of set of word. I am taking the unique characters length. Unique characters, how many unique characters are there in the string? Then count is equal to 1. Result is equal to 0. While S, if S is greater or equal to 8, can take is equal to 8. If it is greater than 8, I can take 8, right? 8 characters. Else, I can take only the S, the remaining characters. Like, see here only there are 6 characters. I will take that 6 into my result. If that is greater than 8, see here 22 is greater than 8. Yes. In that time, I will take the 8. This count variable acts as a whether we want to do 1 push, 2 push, or 3 push, like that. Okay. Here I have used the count. S is equal to S minus can take. Count plus is equal to 1. Fine. And then returning the result. Let me submit it. Yes, it is submitted successfully. Now, this is the optimal approach. So, what is the time complexity and space complexity? See here, what is the time complexity and space complexity? Space complexity is O of 1 because we haven't used anything. But time complexity is how many times our loop will run. Just guess how many times our loop run. I can say our loop run only for 4 times. Only for 4 times. So I can say it is almost constant. Yes, right. Although it is 26, first I will minus 8. It will be what? 18. Again I will minus 8. It will be what? 10. Again I will minus 8. It will be what? 2. Again I will minus 8 or minus 2. I will minus 2. It will be 0. 1 step, 2 step, 3 step, 4 step. So totally 4 step. So maximum possible is 4. We can take as a constant. Fine. So this is the time complexity and space complexity. Thank you.